Welcome to day 4, tangent and normal lines. We talked about tangent lines the other day. Tangent lines, we're going to need three things to write an equation of a tangent line. We're going to need an x value, which will be given to you, a y value, in which we can find out by plugging it into the original function, and the slope. And we've talked about this the last couple of days. Another word for slope is the derivative. We're going to use the derivative to write the equation of the tangent line, and then we'll talk about what a normal line means. So again, we're using this form to write our linear equation every single time. And when we want a tangent line, we need the slope. So f of x of 1 is when I plug in the x, that's my y value. And f prime of x1 is the slope that I want for that particular point. So I need three things. Three things I need: x value given to you, a y value which may be given to you, or I'm going to plug it in to the function to get it, and I need a slope, which I'm going to take the derivative, and I'm going to plug this x value in there, and that's how I get the slope. Okay, and then the other thing I want to talk about is something called a normal line. A normal line is perpendicular to the tangent line. Okay, so all I need to do to write a normal line is change the slope. Remember, perpendicular means slopes are opposite and reciprocal. So let's go through an example. Okay, I'm not going to use a long way to find derivatives. I'm going to use a short one. But first I need to find what I have. I have an x value. X equals 3. I need to find the y value. So y equals equal to f of 3, which is 3 squared, which is 9. So I have the point 3, 9. Which you can see I have already marked here on the graph. Then I need to find the derivative. So f prime of x is, well, if this is x squared, the derivative is 2x. And then f prime of 3, because that's my given x value, is equal to 6. So now I can write my tangent line equation. Y equals 6, x minus 3 plus 9. That is the slope of the tangent line. And I can show that on the graph over here by drawing this tangent line best I can. This is my tangent line. Okay, my normal line, well, if my slope is equal to 6, my perpendicular slope is equal to negative 1/6. So my normal line is going to be pretty similar, but y equals negative 1/6 x minus 3 plus 9. And I can show this on the graph by doing this to the best of my ability. And this pink one is the normal line. Notice that it is perpendicular to the tangent line to the best of my ability. Okay, here's my function. Here's my given x value. I need a y value by plugging in negative 1. And I get f of negative 1 is equal to 6. So I have the point negative 1/6. Now I have to find the derivative of this function. So f prime of x is equal to 3x squared minus 4x minus 4. But I really want it for this specific x value of negative 1. So f prime of negative 1 is going to be 3, negative 1 squared minus 4, negative 1 minus 4. So I get f prime of negative 1 is equal to 3. And this is my slope of my tangent. So when I want to write my equations, my tangent line equation is going to be y equals 3 x plus 1 plus 6. And my normal is going to be very similar, y equals, but now negative 1/3 perpendicular, x plus 1 plus 6. And those are my two equations that I'm looking for. So again, I'm going to do tangent or normal line, I have my function, I have my given x value, but the problem with this function, I don't like the form, so I'm going to rewrite it as this. Okay, because I can't take the derivative in another form. I can't find the value. I could plug 1 in here and do g of 1 is going to be 3 over 1 squared plus 8 over the square root of 1, which is just 11. So I have the point 1 comma 11. So I don't have to rewrite it to find the y value. I need to rewrite it to take the derivative. So when I take this derivative, g prime of x is going to be negative 6x to the negative 3 plus 4x to the negative 1/2, using my rules of multiplying coefficient and exponent and subtracting 1 from the exponent. And now I have to do g prime of 1 by plugging 1 in here. And I made it really easy because 1 to any power is just 1. So g prime of 1 is going to be negative 6 plus 4, which is negative 2. And my tangent, which is my tangent line slope. This is my slope of my tangent. So I get y equals negative 2 x minus 1 plus 11. And my normal is y equals positive 1/2 x minus 1 plus 11. Here's my function, here's my x value. I'm making it easy using x equals 1. So h of 1 is negative 5 over the cube root of 1 plus 4, 1 to the third. And I get my y value of negative 1, so I have the point 1 comma negative 1. I'm going to rewrite this because I cannot take the derivative in this form. I get negative 5x to the negative 1/3 plus 4x to the third. And now I can take its derivative. H prime of x is equal to positive 5 over 3 x to the negative 4/3 plus 12 x squared. Okay, and now I have to find the derivative at that one special point using x equals 1. I get 5/3, 1 to the negative 4/3 plus 12, 1 squared. And like I said, the great thing about 1 to any power is equal to 1, so h prime of 1 is equal to 5/3 plus 12, which is 41 over 3. And this is my slope of my tangent. So my tangent line equation, y equals 41 over 3, just a fraction, who cares, x minus 1, using the x and y value. And my normal line equation is going to be y equals negative 3 over 41 when I take the opposite reciprocal. X minus 1 minus 1. And there is my tangent and normal line. Okay, I made this one a little bit more difficult. I didn't use x equals 1, I use x equals 16. I'm going to plug 16 in here. And I'm going to reduce it. The fourth root of 16 is 2, so it's 2 times 2 minus 4. 16 1/2 is 4. So this is going to be 4 minus 16, which is equal to negative 12. So I have the point 16 comma negative 12 as my x and my y. I'm going to rewrite this as 2x to the 1/4 minus 4x to the 1/2. So I can take its derivative. It's hard to take the derivative when it's not in the right form. H prime of x is equal to 2 times a fourth is 1/2. X to the negative 3/4 minus 4 times that is 2x to the negative 1/2. Now I have to do it for the specific value of 16. So h prime of 16 is equal to 1/2 16 to the negative 3/4 minus 2 16 to the negative 1/2. So now we have to do a little bit of simplification of all that. So rewriting things, 16 to the negative 3/4 is 1 over the 4th root of 16 to the 3rd, which is the 4th root of 16 is 2 times 3 is, so it's 1/8. 16 to the negative 1/2 is 1 over the square root of 16, which is equal to 1/4. So you get 1/16 minus 1/2. So you get h prime of 16 is equal to negative 7 over 16. And that is my slope. So when I do my tangent line, y equals negative 7 over 16, x minus 16 minus 12, and my normal line, y equals 16 over 7, x minus 16 minus 12.